This is a question from discrete mathematics. Suppose A is a finite set with n elements. The number of elements and the rank of the largest equivalence relation on a set A are. So, what is an equivalence relation? A relation R is said to be an equivalence relation if it is reflexive, symmetric, and transitive. So, what is reflexive? A relation R on a set A is said to be reflexive if for all x belongs to A, x is related to x. This is reflexive. Second property is symmetric. A relation R on a set A is said to be symmetric if for any x comma y, x is related to y, then y is related to x. This is said to be the symmetric property. Now third one is transitive. Transitive. A relation R on a set A is said to be transitive if x is related to y and y is related to z, then x is related to z. This is said to be the transitive property. So now let's see the largest number of elements on a set A with n elements that is possible, which is equivalence. So if we have n elements, then maximum we can have n square elements in the largest equivalence relation. So this is the answer for the largest equivalence relation with n elements. The answer is n square. Now let's see the rank of the largest equivalence relation. To calculate the rank, suppose n is equal to 3. If n is equal to 3, then it contains 3 elements A1, A2 and A3. Now let's draw the equivalence relation. If the largest possible equivalence relation contains every element is related to every other element. So the answer would be n square here. If n is equal to 3, it will be 9. So the relation A can be denoted as 1, 1, 1, 1, 1, 1, 1, 1, 1. The elements are A1, A2, A3. Here also A1, A2, A3. This means that since it's follow reflexive, all the diagonal elements are related. So A1 is related to A1, it means this. A2 is related to A2, this means this. And A3 is related to A3. So reflexive property satisfied. Similarly, symmetric property. A1 is related to A2 and A2 is related to A1. Similarly, all these properties reflexive, symmetric and transitive is being held by this relation. Now let's calculate the rank. We can rewrite the equation as R2 implies R2 minus R1 and R3 implies R3 minus R1. So the relation can be rewritten as follows: 1, 1, 1, 0, 0, 0, 0, 0, 0. So this means that rank of this relation matrix is equal to 1. Now what is rank? Rank of an equivalence matrix is the number of equivalence classes induced. Here only one equivalence class is there. So as a result, rank is equal to 1 and the number of elements in the largest possible equivalence relation is n square. So the correct answer is option C, n square, 1.